Okay. Thank you for the very kind introduction. And by the way, if you have the doridcon app installed, please update. There's a bug fix in the Play Store. Oh, sorry. Okay, who knows what DAS is? Cells? Yeah, exactly. So cells. Well, the human body is interesting. I don't know if you know, but there are over 100 billion cells in our body, and 50 billion die every day. So basically, our body will be renewed every day, and it takes about 10 years to be completely a new person, kind of. And more interesting is that those cells are not only replaced by the body, but some of them get stronger, get better. In other words, the human body is refactoring our cells. And as already said, or as has been already introduced, my name is Hannes and I'm working at Tickaroo. And today we are talking about refactoring the Plaid app. Please raise your hand if you know what the Plaid app is. Okay, quite a few. But, or at least I would expect a little bit more, because it's quite popular in the developer community, I would say. Another question. Please raise your hand if you have been slowed down by bad code. So why do you write bad code? Just think about it. And if you have spotted bad code, then you may want to touch it, to change it, right? You make a little change here, a little change there. But then you have to fear to break it, right? And that's where this is very useful. Test-driven development. Test-driven development is basically the only way to ensure that you can refactor, that you can change your code without having to fear to break it. But before we get started, I want to touch some key principles, like solid. Who knows what solid is or what solid stands for? Please raise your hand. Yeah, a good number. So I don't cover all of them, but basically they were 5 principles introduced by Uncle Bob, or Robert C. Martins, as his real name is, but he's better known as Uncle Bob. And I will only talk about the single responsibility, because for this talk it's the most important one. So single responsibility, that means a class should only be touched by you as developer for one reason. And it should only be responsible for one thing. So what does that mean? What's the problem with that class? Who can spot it? Please speak out. Yeah. Scream out. Yeah, exactly. It does too many. It does print, it has page. And actually, we could refactor that to something like this. We could make a book, which is only responsible for keeping track of pages, and a printer, and the printer gets the book. So now, we only have to touch book if we want to change something with pages. And if we want to change the printer implementation, we touch the printer class. So this actually prevents us from making bugs, kind of. Or at least it prevents us from doing stupid things. So now think about activities and fragments. What is the single responsibility of them? Do they have single responsibility at all? Another important thing is immutability. So the way I think of immutability is sitting in a baseball stadium. And if you were in the tribune somewhere in the middle and you get hungry during the match, because we all know baseball could take a long time, and you will scream over to the vendor to pass you a hot dog, but you were sitting in the middle, so you can't stand up. But what you will do is you scream at them and say, hey, pass me a hot dog. And what he will do is he will give your hot dog to the first person sitting in your row, and he will pass it to his neighbor, and he will pass it to his neighbor until you have it in your hand. And basically, you want an immutable hot dog, because you don't want that someone is touching your hot dog, someone eating a bit of the hot dog, right? And that's the same with programming. If you pass around objects, you don't want that other components touch them, modify them, because that only introduces bugs and makes it harder for you to debug. And moreover, if you use it in multi-threaded environment, this ensures that you don't have race conditions. So how do we do immutable classes in the Java world? Well, there's a nice feature or a nice library called autovalue. Who have heard of autovalue before? Yeah, good. So I don't have to introduce that long. It's an annotation processor by Google, and basically it generates code out of this class. So you annotate an abstract class as autovalue. Then you can also add some extensions like implements parsable, because there are some extensions for this annotation processor, which automatically generates, for instance, the parsable code, the parsable interface for you. And there's more. You can do some add JSON annotation for various JSON serializers. And you can also annotate that with add column name to get a cursor mapper from SQL cursor to your database. And finally, instantiated, it will be something like that. So you write the new class that will be generated is called autovalue underscore and your class name. And it has package private visibility. So it's not possible to instantiate it without within another package. So this prevents us for creating an instance of hotdog without wanting to make it immutable. Okay, let's talk about model view controller just for a second. So model view controller has been invented by Wayne Scout in 1979, and he was a Smalltalk programmer. And his way of thinking or defining model view presenter was, okay, there's a model, and the view, which was an UI widget, for instance, was observing this model. And then there was a controller, and the controller was manipulating the model, and then the view will be updated automatically because it was observing the model, right? So there was not one big view, there was not one big controller, like we would declare activities or fragments nowadays as controllers. But his idea was mainly something like this. If you have a UI like that, or a screen, then every checkbox has its own click listener, which is the controller. The checkbox will observe a Boolean flag from a model class, and that's the model class, actually. And the view is just this UI widget. And now think about what you define as model view controller, or at least the most of us do. We have this big activity with a lot of responsibilities. We talked about single responsibility before. And this kind of reasoning about model view controller, from my point of view, is definitely better. And we should definitely go away from this idea to have one big screen with one big controller with one model. We should split it to smaller UI pieces. Okay, so now let's start with Plaid. So Plaid was built by Nick Butcher, who's a Google Android developer advocate. And he has built this app. And the main idea of this app is you can have a list of design inspirational sources like Dribbly and Designer News, and so on. So there are some sources he fetches over HTTP and displays those items in this list. And it's quite popular on GitHub. It has over 5,000 stars, and it's still under development, and quite common in the Android development community, I would say. So let's have a quick look. So the app starts like that. You can scroll. Oh yeah, you have different sources, and you can enable each source. So you have a source like popular Dribbly, and also from design stories and so on. And it has some really, really nice UI with material design, and it's really, really good. It has a really great user experience, but as we will see later, from the code quality or from the separation of concerns, we talked before, single responsibility, there may be some issues. Okay, you can also uncheck, and you see that the list is always responding to your filter settings. Okay, just another short video. You can also search for topics like hello, and then you can say, I will add this hello to my source list. So basically, I can add a new filter, and then it will be displayed in this list. So you can add arbitrary many sources and enable and disable them. Yeah, it also has some details, really nice animations, all the material stuff. It's really, really awesome. Okay, so the problem is no clear separation. It uses async task, which is not a problem per se, but it also uses Android services, which is also great. But, or at least from my point of view, it's not perfect to use shared preferences for storing a list of sources which are enabled and disabled. But yeah, I know people do that to quickly get started and you don't have to write ORMs and so on. But from my point of view, a database will be better and we will actually refactor that to use a database afterwards. So the first code smells lead to also UIs smells. So for instance, we see that no internet connection and the loading indicator at the same time. Why? Because there are many components manipulating the state of the UI at the same time. Or actually, there are not many components, there are many functions in the activity doing that. There are also other things like, I actually don't have activated any source, but there are sources displayed. So you see, there are some kind of little issues, and we're going to refactor them, or at least refactor the code a little bit to avoid such issues. Okay, let's take a closer look at the architecture. So the home activity was basically the list of the items I showed before. And basically it contains a connectivity manager. The connectivity manager listens for internet connection and not internet connection and displays the arrow state with no internet connection or none. Then there are a lot of animations which also check for internet connection, check for should loading be displayed, and so on. So those two big components are manipulating the state of the UI. But there is more. There's the feed adapter, which is the recycle view adapter for the items in the list. There's the filter adapter, which is the adapter for the filter, where we can enable and disable sources. And if we add a new component, we start the search activity. If we want to add a new source, we start the search activity, and then with on activity result, we get back the new source we have enabled. And then the main activity will store that somehow. Okay, so on activity result gets the source back and it stores in the filter adapter. Okay, so the filter adapter has a list of sources, and basically when we add a new source, we add it to the filter adapter. Then there is a data manager, and the data manager also has a reference to the filter adapter, because whenever we get a new, we want to load new sources, we query this filter adapter to get the list of sources. And basically the data manager also contains a list of calls. It uses retrofit to make calls, and it stores that in a hash map, because afterwards it has to clean up the calls when, for instance, we rotate the screen and so on. And it also contains some page index, so it has some pagination feature. So when you scroll down, it loads the next page, the next pages from your sources, and so on. And here it stores the kind of, now with this source I'm on page 1, with this source I'm on page 2, and so on, and it counts that on. So the data manager is also quite a huge class. And as always said, the filter adapter is connected directly to the data manager. And the data manager is connected to the feed adapter. The feed adapter is connected to the filter adapter. And the filter adapter is connected to the source manager, which is to share the sources in the shared preferences. So you see a little problem here with this architecture. All these arrows pointing around. And finally, the home activity also knows about the data manager because it has to cancel it on destroy. Okay, refactoring. So how do we start with refactoring? As already said, we can't really touch anything without failing to break it, without having tests. And usually the app connects to the internet and brings some data from the internet, from Dribbly, designer stories, designer depot, and so on. So what we want is to mock the internet, to create reproducible tests, because we want the test to be always the same. Otherwise, we can't compare it if it fails or not, right? So what we can do, or at least what I usually do, is I use this tool called Postman. I grab the URL in there, and then I get the feed as answer. Then I store this JSON response into a file. And there is a well, it is a Java Gradle, not feature, but yeah, a Java Gradle way. Usually there are resources in your source/test/resources folder. You can put in resources like in the web development. That's quite common. And we also can do that since the Android Gradle plugin 1.5, I think, on Android. And then we can basically load this class, so we don't have to hardcode this JSON string, or this huge JSON file in a string in a Java file. We can load it dynamically. Then we also need a mock server, right? And there is obviously from Square, who else, offering along with OK HTTP and OK HTTP mock server we can use. And finally, to stick that in, because Plaid has no dependency injection, we need a rule. And the JUnit rule allows us to, we will see a code quite after, allows us to hook in this mock server without changing the actual production code. Okay? And there are some links where you can find a little bit more about this rule stuff from Artem Sinatolin, Quality Matters. That's also quite popular, I guess. But this rule thing is a little bit, not tricky, but a little bit strange if you haven't get in touch with it. Quality Matters might be a good starting point. So how this could look like. We want to write an activity test for our home activity. So we use Espresso. We use that rule with the @mock server. So we automatically use, instead of OK HTTP, this OK HTTP mock server. And then we can say server and queue the new mock response with the data from our JSON file, which we have stored previously in the resources folder. And then we basically say, OK, on view with the ID, verify that it is displayed. And we could also write some custom matches, like to count the items in the recycler view. And since we are always getting the same JSON feed, there are always the same items displayed in this recycler view, right? But there's more. That's only the happy path, right? We tested. We also have to test what happens if, for instance, the server returns HTTP status code 500, and so on. So I have skipped that yet for this session because it's obviously too long. But I guess you get the point, right? Okay, let's talk about the clean architecture a little bit, because so far we talked a little bit about model view controller, but actually this is just a design pattern to display, to separate the view, the UI, from your model. And it's not an architecture. So please raise your hands if you are familiar with the clean architecture. Oh yeah, great. So I don't have to explain it in detail. But basically on the right, you see entities. Entities are just Java objects. And then there is an interactor. And the interactor loads entities. And then there's this dotted line, which means there's a boundary. There's an interface. Then the presenter will get the result from the interactor, ideally creates a presentation model. And in this presentation model contains all the information the UI needs to display it. So, for instance, if the color of a button should be red and not green, or it depends on the state of the model, this presentation model will already pre-optimize that for the view so that the view is pretty dumb. The view gets this model and only displays it. So that's the clean architecture. And people tend to use cases and introduce interactor and repository pattern and so on. But see, the thing with this is a guideline. And there's a very smart guy called Jesse Wilson. And he has written this very inspiring blog post about breaking the rules. So what he basically says is, if you are new, for instance, he said, I'm not a designer and I'm new in this topic. I don't know how to design an app. So there are the material guidelines and I will follow them because I don't know how to do it better. And the same is true for the clean architecture. If you are new and you don't know how to separate your concerns and you structure your UI, decouple your UI from the rest and build an architecture for your app, please follow this clean architecture. But we should get to the point where we have that in our blood, in our mind, all the time we write. So we don't have to write, oh, that's an interactor, oh, that's a presenter, oh, that's an entity. Right? And that's basically what he says. So back to our pretty arrows. How could we refactor that? So the first thing is the source manager. The source manager is clearly some kind of business logic, so it should interact directly with the data manager, right? So what we do is there's a shortcut in IntelliJ. We say, extract interface. We make an interface out of the source manager, providing us all the public API, all the public methods that can be called. Then we create. Oh, sorry, there was an error. Okay, I don't know. My bad. So then we create a source DAO. DAO stands for Data Access Object because we now want to interact with a database. And we make this DAO by using the adapter pattern. We wrap it in a little class that implements the same source manager interface as it has been before. But actually then we use the source DAO, which uses reactive programming, RxJava. So who's familiar with RxJava? Please raise your hands. Oh, great. That's awesome. But why are you actually using RxJava? Please speak out. Because of threading? That's a trend. Yeah, that's true. Well, don't get me wrong, RxJava is awesome. But just saying it's a trend, it's not really a good point of view, right? Separation of concerns? Yeah, a little bit, but yeah, okay, let's say for now. Sorry? You get pretty code? Yeah, but actually, if you think of pretty code, you may think all these operators like flat map and so on, right? Error handling on error, yeah, exactly. But see, the main thing with reactive programming is that it basically is that. Who knows what this class is and who has used it before? Yeah. So basically, reactive programming is all about observing a data. Actually, it is a stream, okay, that's a little bit more than this class offers us. But it's just observing data. Okay, so our source DAO interacts with our SQLite database. And we use the library from Square called SQLite, which is a reactive wrapper around it. So basically, it provides us a way to say, okay, query, and we pass the select statement in, and we get an observable of our list of items out, for instance. Okay? And the source DAO looks like this. So I've written that in Kotlin because I really like Kotlin. And it offers get all sources, enable sources, to disable and enable a source, and insert and delete. Then we also talked about immutability before. Obviously, we want our objects to be immutable. So we annotate, even if we use Kotlin, I use auto-value there and not Kotlin's data class. And we annotate that fields with the column name and this call name and call enabled is basically just a string, static final string field with the constant. Okay, and then let's start with TDD actually. So far we just have written this espresso test to see if everything works if we changed the source DAO instead of the source manager. So with TDD, we follow these rules. First, we will write a failing test. And that sounds a little bit strange, I know. But we will see what I mean with that. And then we write just enough tests to get pass with our unit tests, okay? And then we repeat over that. So basically, we write a test like, okay, insert that item, and we assert that it returns 1 because we have inserted one item. So the test will fail now. Obviously, it will fail because we haven't implemented it yet. So now we implement it. And then we implemented something like this. Okay? And then the unit test passes. Then we go ahead and write a little bit more of a unit test. Now we write a query to get out the inserted item. And now it again fails because we haven't implemented it yet. Then we implement this one. And finally, we are done. Okay, so back to our refactoring. The source manager is now source DAO. And the data manager interacts with this source DAO. So we also run our our espresso test, and it should pass. And now we change the feed adapter. The feed adapter don't interact with the filter adapter anymore, but they are just observing the data manager. So now they have references to the data manager, but at least there are not circular things as we had seen before. Who knows what this is? Yeah. It's the cache coherence protocol. Basically, in your multi-CPU core, every core has a cache. And each cache has to synchronize his state with another core in your CPU. And they are doing that by using an event bus. Why are they using an event bus? Because they want to, because otherwise it's hard to implement that coherence algorithm. And they rely on a feature that only one core is sending an event over the event bus at a time. So why I'm talking about the event bus? Because people use event bus to separate the UI from the business logic, let's say. And that's fine. But the thing about event bus is it can get out of hands quickly. Then you use the event bus over a little there, over a little here, just for things where you actually want to use the observer pattern. And people tend to forget about the observer pattern. So we had talked about reactive, and then people started with the idea of our reactive event bus, our X bus. But please don't do that. That doesn't make sense. So we talked about before that the reactive program is all about observing data or observing something. So basically, instead of observing on an event bus, observe on that data object directly. That makes much more sense. Okay, so we will split our view, presenter, and model. Now we are going to implement the model view presenter pattern, but I'm pretty sure that who's not familiar with that pattern, because I think the most of you are. Yeah, everyone. So don't have to talk about that. But how do we test that? The nice thing about this pattern is that we can test each component separately. So for the view, we can mock a presenter and simply say, okay, now display the loading indicator, now display the content, now display error. And we write a simple test for that and we're done. The same for the presenter. For the presenter, we mock the view and maybe the model and see if the presenter calls the right view function, the right method like show content. And the model, actually, we already have written tests for the model, like the database query. Okay, single responsibility. Now the data manager previously, the data manager has a lot of things to do, like making calls and so on. So now we refactor that. We create little classes, like the route. The route is basically just making an HTTP call to a backend endpoint. The router actually bundles all endpoints together, so we have a list of all routes in there. Then we have a page, because we want a pagination, and the responsibility of that class is just to say, we are at page 1, we are at page 2, we are at page 3, and so on. And now let's put that all together to something like that. We have the source DAO, the route, the router, and the page. And now we connect that with RxJava. We make them all observable. So what does that mean? Now, I will show you a short video when we start with that screen. So we will now collapse the filter drawer on the right and enable a source. Right now, there's no source activated. But the state now is the filter fragment, which is where we saw the list of filters, and the filter presenters are connected to the source DAO, and basically they have made a query like, get me all filters. And on the left side, you see the home activity, which is connected through all that page, router, source DAO thing, to load the items. And what now happens is, if we click here and enable a source, then actually a UI event will be triggered here, right? This UI event goes down to the source DAO. From the source DAO, it goes to the SQLite database. And now happens something really, really interesting. Since it wasn't observable, this library will simply rerun the queries. And then, please note that even if the icon from popular dribblies is now displayed as enabled, it hasn't been enabled because of your click. That's a little bit an issue of this diagram. But now it goes the way back from your source DAO to the presenter, and now with the new list of filters, of sources, where this popular dribblies is enabled. And then we simply say notify dataset changed. Because we have this source made immutable. We can say source.set enable true. That's not possible in our API because it's immutable. So the only thing who is able to edit the list of filters or the list of sources is the source DAO or the SQLite, the underlying database. We always, on every change, get a new list of items out. And the interesting fact is that on the left side, the same query will be rerun. The DAO will inform the root that it has been changed. It will add the new root. The root will be passed along the way up because it's all observable. And finally displays the item in the home activity. So here are the items. And the nice feature about that is that we have an unidirectional data flow. There are no presenter-to-presenter communication. They don't communicate with each other at all. There's no need for that. They communicate all the way down, all the way up. Okay? And the same for services. If we start or we make a new post to Dribbly, which is also possible from this Plaid app, we would start just an intent service saying, okay, now insert that item. And then we put that in the database, and all the views will be updated automatically because we are observing by RxJava the database. And we have this unidirectional data flow. Okay, see, the thing is, we shouldn't worry too much about our UI, and that's actually a problem from my point of view with Scrum, because we already want to iterate fast and show the customers new things, and then we really focus on the UI. But we really should focus more on the model, on your business logic. And so we have refactored that. Now we have this unidirectional data flow. Everything is cool, but actually we are in the same situation as it was before. So we have spent 2 months on that, refactoring that app. The question is who pays us for that refactoring, because customers usually don't want to pay for bug fixing and for refactoring. So those two guys, or basically Gijit from the Google team said that, who cares about architecture? And that's right. It's not that important about the architecture because the user only cares about the UI. But we want to move fast, right? And we only can move fast if we do test-driven development, if we care about the architecture. And as you see, this automatically updating results in less UI bugs, which is a better user experience. Okay, so move fast without fearing breaking things with MVVM. I meant test-driven development. And keep in mind that the code you write today will be legacy code tomorrow, and you better be prepared for that. Basically, there will be war out there with you and your code you have written yesterday and some friendly fire from some coworkers' code. And in the human body is doing the same. The cells in our human body today are legacy cells tomorrow. So we better build cell-alike components in our code by applying a clean architecture, by taking care of unidirectional data flow, and there's also topics and talks in this conference about this unidirectional data flow, about other patterns like Redux, and so on. So last but not least, I want to thank my employer for supporting me, and we are hiring. And if you have questions, I think we have 2 minutes left.
For your questions, I have a microphone over here. Just raise your hand. One.
You talked about mocking JSON objects and do unit testing with mocked objects. How can I effectively test my mocked data if the response from the API changes every day? If the structure keeps on changing, how can I maybe implement a good flow to be aware of these changes and to keep the tests working with actualized JSON?
I can't hear you very well because the speakers are in your direction. Could you please repeat the last part? How could I?
How can I keep on testing with mocked data when the response from the API changes every day? If the structure, if there's an API team working on the API and the response changes every day, how can I keep the unit tests working?
You mean how do you test when... No, sorry, I don't get it. You mean how to test the unit, how to test various responses at the same time?
No, you just have an API and the response of the API, the structure of the response changes often. How can I keep on running this unit test? Well,
yeah, that's something you have to adjust. That's a problem, but that's not really a problem, I would say, but that happens. That's not an issue. That you have to do that for your app anyway. That's not an issue for your JSON. Actually, with that approach, you just have to change the JSON deserializing stuff and not really the unit test. The unit test will work fine. But you have to refetch the JSON feed and store it in the resource folder, yeah.
Guys, please keep seated and keep quiet until for the next 3 minutes or so, because there are some more questions and we want to give people the chance to ask those questions. We will have plenty of time to find the next room for the next talk. Thank you.
Hi, my question was, we are also trying to use like MVP pattern and also like this reactive Java and
wait a second.
objects.
I have to step up. I can't hear you really well. Okay, now. Now I hear.
Okay, so we were using an MVP pattern with RxJava with like observables and immutable objects, and I faced one issue. For example, we are having like a huge like card in our recycler view, and like all of this is immutable. And basically, we don't have to interact with it a lot. And there is like a small, tiny thing that may be changed. And with all the observables, we are making this like going down, saying that we change it. And whenever we are changing it, we are creating a new object and replacing the old object with a new object, like and notify data saying changed.
Yeah.
The issue I faced, it was like not really nicely updated. So basically, the whole view was like blinking, and like even if we need to update like a small, really small part, because like the whole object is immutable. So for me, it was like my solution was to keep like these small changes mutable and the whole object immutable. But it's like not exactly the
that's
right
strange
approach.
that we do at work pretty the same thing, and we do a lot with item animator. For instance, I'm working on the Kicker app, and here we have some match result displayed, and we have some tip guessing feature, so we can flip these cells by using this unidirectional data flow and a custom recycler view item animator, and we never have faced such a problem as you said with blinking and so on.
No, like it was the same object. For example, there is like a like button.
Yeah,
And then,
I get your point.
Like for example, and there's like you need only to make this like button like liked, for example, and the whole like picture which is over there.
Yeah.
It's like whenever we are changing it, we are like basically updating the object and it's like changing like one to another one, and it just doesn't look that nice.
Okay. Yeah, I never have faced this issue, but the problem I see with your approach is that now you get a little bit away from the traditional, let's say from the Reens card model view controller thing, because now you have a state in your UI and you have a state in your model, and maybe they are not in the same state, which may or may not be an issue, but once you start with that, it's just one step further to do much uglier things, I would say. But to be honest, I never have faced such an issue regarding immutability, blinking UI, and performance of creating the list every time again. But maybe we can talk about it later, or you can explain me a little bit better.
Thank you. I think we have one last question before we have to break up here.
Hi. You said that you are still using auto value besides instead of Kotlin data class.
Yeah.
Could you say why?
Basically, because of the extension function they provide by auto value, there are libraries for auto value like auto value parsable. So basically, I can make my class implement parsable, and my auto value annotated class parsable, and it does all the rest for me. It generates the parsable interface automatically.
So you mean the extensions, because of the auto value extensions?
Genau, exactly, yeah, because of the auto value extensions. That's the big point for me. Yeah.
Okay, thank you.
Thanks.
Thank you. Thanks, Hannes, again.
Thank you, everybody.